Hello. Today we will be looking at the lab 5 for Excel, and we will be doing the data analysis using Excel. Previously we used all of Python to do the data analysis, but now we're going to be using a little simpler and a more structured format for the data analysis. So here we were given a data set which was recorded from a sensor and a site. About I am assuming that it's from an experiment, like a physics experiment, if I'm not wrong. So we have a different set of values here, and this is a complete raw data set which has, as you can see, there's an there are errors and there are empty sets and stuff like that, which we will be dealing with. So Lab 5 had different issues which we had to deal with and we had to work with. So the first one was working with just loading the raw data. So this is data which has been loaded from another data set, like from a downloaded data set called data.csv. So we first converted, we got that data into this, and hence you can see that it's a very well formatted data. Like it gives it's being, because CSV is comma separated values, where this just gave us all the values in the CSV into specific Excel columns. So after that was done, we had to go ahead and create another column called data, which dealt with cleaning the data. So I had made one data column myself, and it works with, so basically we started with first converting time our timestamp here to a normal time timestamp, which takes the value YYMMDD and hours, minutes, and seconds for our future analysis. And if you notice, I have given it a custom number format so that we could use these values throughout for our analysis. And all the empty values were given a null statement, hence they all are zero. And this is just a concatenated global sensor ID, which gives us an ID, site ID and sensor ID mashup in a way. So that really helps us with our analysis and gives very like cleaned up data to, as that's one of the first few steps of data analysis. So this was the first step of data analysis, where we do the cleaning and the wrangling of data. Hence, the cleaning and wrangling has been done here. We do this similarly with other data sets using Python, but for now, we use Excel, which made our values pretty easy, which made our cleaning pretty easy. And if you notice, these all have been made into arrays, the value, sensor ID, and the site ID. So all of them have a specific uh, relation, right? So at site ID 2, at this time, at site ID 2 and sensor ID 1, the value which was gained was 0. So all the values above 100 have been removed. And as you can see, that's pretty well clean data. Moving on, we had to do a little summary of the data. So we have around 2,304 values of data, like just rows, not the total value. The max reading we noticed is 100 because we have removed all the values below 100. The minimum reading for all the data is 0, and the average reading of the data is 41.9. The maximum reading for site 2 is 100, again, because most of the sites have a maximum only of 100. And the number of readings for sensor 2 at site 1, that is 2 comma 1, because that's the legend we have worked with, is 174. We'll come back to this after we have seen our chart. Moving on, this is when we do a little bit of more of transformation of data, or not exactly visualization, but to in the data analysis terms, this is more of our, how do I put this? It's more about when we describe our data. So this gives us a really big great idea of how our data is separated, and all the empty files have been given a red tinge because there's no value. And we've added a nice sparkle line data. Uh, I mispronouncing the name. Sparklines, yes, sorry. Sparklines added on this site because we really needed to. It's like a mini version of just seeing what our analysis looks like. Which one is high, which one is low. It's a small chart which is being put in each cell. Moving on, before that, yeah, this was all done with the help of a pivot table. So we choose first, we selected the data here and we converted into a pivot table, and then we gave it so we wanted columns as the global sensor IDs, which is 1 2 3, which is one slash one, I mean 1_1, 1_2, and so on. We wanted the timestamp, so we didn't really want all the timestamps. We wanted the specific timestamps with which this all data worked. As you can clearly see here, on 7th January at 12 a.m., we had the sensor ID 11 had a value of 24. And if you see, there's a bunch of set which has, like, all the sensor IDs here have specific values. Hence, the transform data just gave us a better reading of this. And lastly, we made a scatter plot which helped us understand what the trend line was for 1_1, and that data is linear. I was unfortunately not able to make a histogram. I am still little lost about it, and I shall read about it more. But for now, this is what I've learned, and it's a linear data set, as it's noticed here. Yes, that's pretty much it. And this was a fun activity. This was really helpful. Thank you.